Welcome to our new chapter in the Python adventure Data Structures. Today we're exploring one of Python's most fundamental data structures, lists. Think of lists as the Swiss Army knife in your Python toolkit. Versatile and easy to use, they are perfect for storing and manipulating a collection of items. Let's jump in and discover the power and flexibility of Python lists. Picture a list as a dynamic row of boxes, each capable of holding just about anything you can imagine: numbers, letters, other lists, or even that leftover pizza from last night's coding session. In Python, lists are your go-to for storing an ordered collection of items, ready to be accessed, modified, and danced around with your code. In this colorful example, my underscore list comfortably houses an integer, a string, and a float. It's a harmonious little party of data types, each item sitting snugly in its own spot. Creating a list in Python is as easy as pie and just as satisfying. You can start with an empty list or fill it with items right off the bat. It's like packing for a vacation. Start with an empty suitcase and then add in what you need. In the first example, we have an empty list, ready to be filled. In the second, we've already packed a few essentials. Notice how straightforward it is. Just items separated by commas, all cozied up inside square brackets. Accessing items in a list is like picking a book from a shelf. You just need to know its position. In Python, this position is called the index, and it starts at 0, not 1. So the first item is at index 0, the second at index 1, and so on. Here, we easily grab the first and third items from our vacation packing list, just by using their indexes. But what about trying to access an index that doesn't exist? Let's see what happens. Attempting to access a non-existent index throws an index error, a way Python tells you, "Hey, you're looking for something that isn't there." Always a good reminder to stay within bounds. Python lists are like elastic bands, stretchable with more items. Let's start by adding a single item using append. This method tacks an item onto the end of your list, like adding a new guest to the end of a party invitation list. Now, what if you want to add an item at a specific spot? Use insert. It allows you to specify the position for your new item, squeezing it into your list at just the right place. And for times when one item isn't enough, extend comes to the rescue. It's like opening the gates to let a whole group of items join your list party at once. As in life, sometimes we need to let go of things in our list too. Let's start with remove. You tell it what item to remove, and it makes it vanish, like a magician pulling a rabbit out of a hat. Poof, it's gone. But what if you need to remove an item and keep it for later? That's where pop shines. It not only removes an item, but also returns it, like catching a fish from your list's pond. Sometimes you might want to clear out the whole list, making it as empty as a deserted beach. That's when clear is your friend. It sweeps away all the items, leaving you with a clean slate. Lists are more than just adders and removers. They're also great at organizing. The sort method tidies up your list, ordering the items. Need the order reversed? Just call reverse. And if you ever wonder how many guests are at your list party, len gives you the head count in an instant. With sorting, reversing, and counting, lists become incredibly adept at handling your data in whatever way you need. They're like your personal assistants, eagerly awaiting your next command. Having mastered adding and removing items, let's explore how to walk through, or iterate over, the items in a Python list. Iteration is like going on a treasure hunt through your list, where each item is a potential discovery. The most common way to iterate through a list is using a for loop. It's like assigning a detective to follow each clue in the list. For each item in the list, the for loop executes a block of code. Let's see this in action. In this snippet, our for loop is taking a culinary tour through the favorite underscore foods list. With each iteration, it takes the next food item and performs the print operation. It's a simple yet effective way to process each item in a list. List iteration is not just for printing items, it's a powerhouse for data processing. Whether you're calculating totals, searching for specific items, or transforming data, iterating over a list gives you the power to perform complex operations with ease. Here we're using the for loop to calculate the total sum of numbers in our list. The loop picks each number, adds it to the total, and moves on to the next, tallying up the sum as it goes. One of the most efficient ways to iterate through a list while keeping track of indices is by using the enumerate function. It's like a tour guide who not only shows you each item, but also tells you its number in the sequence. For those who love a dash of elegance, Python offers list comprehensions. This is a sleek and efficient way to create new lists by iterating over existing ones. It's like crafting a beautiful piece of jewelry from raw materials. In this example, we created a new list, squared_numbers, where each number from the original numbers list is squared. List comprehensions make this process concise and visually appealing, and that's how you iterate over lists in Python. From simple loops that walk through each item to sophisticated list comprehensions that transform data in a line of code, iteration is a key skill in Python programming. In Python, a nested list is essentially a list that contains other lists. This can be as simple as a list of lists, or as complex as lists within lists within lists. They're like Russian dolls, where opening one reveals another inside. Here, nested_list contains 3 lists, each with its own type of items: fruits, numbers, and letters. It's a versatile structure that can be used for multi-dimensional data storage. Accessing items in nested lists is like navigating a multi-level building. You first select the floor, the outer list, and then the room, the item in the inner list. Let's fetch an item from our nested list. In these examples, we accessed banana from the first list and C from the third list. We use 2 indices, the first for the outer list and the second for the inner list. Looping through nested lists can be done with nested loops. This is like conducting a thorough search of each floor and room in a building. Here, the outer loop goes through each list in nested_list, and the inner loop goes through each item in these inner lists. It's a systematic way to visit every item. Having mastered iterating over lists and utilizing indices, let's slice into another exciting feature of lists in Python: slicing. Slicing in Python is a way to create a new list out of a segment of an existing one. You specify where to start and end the slice, and Python does the rest. It's like selecting a range of books on a shelf. You choose the start and end points, and you get everything in between. Here we slice the numbers list from index 2 up to, but not including, index 5. The result is a new list containing 2, 3, 4. Notice how the start index is inclusive, but the end index is exclusive. List slicing isn't just about cutting from the middle. You can also omit the start or end index, which tells Python to slice from the beginning or up to the end, respectively. And there's more. You can even specify a step to skip items as you slice. In these examples, we created slices in various ways, from the start up to the end and skipping every other number. It demonstrates how slicing can be tailored to suit your specific needs. And here's a twist. Python also supports negative indices in slicing. Negative indices count from the end of the list backwards. This can be incredibly handy for grabbing elements from the end of a list. Here we used re3 to slice the last 3 numbers from our list. It's a quick and intuitive way to access the tail end of your data. And that's your quick tour of lists in Python. As you can see, lists are incredibly versatile and user-friendly. They are an essential part of Python programming and a great way to store and manipulate data. Experiment with lists, try out their methods, and see how they can make your coding tasks easier. Join us next time as we continue exploring Python's data structures in TechBuster, where we make coding both fun and enlightening.